Okay, so we've been looking a lot about motion. We've talked about distance, how far you traveled, displacement, looking at how far you are from where you originally started. Remember, it's displacement only worries about that beginning and end position. Displacement is also based on direction, so east is positive, west is negative. We looked at graphs of distance and time graphs. We've looked at speed, which is how fast you're traveling. Speed is looking at your distance over your time. We've talked about velocity, which is your displacement over your time, which, remember, your displacement has to have that your velocity and your displacement have to have that directionality. And then last time we looked at acceleration. And remember, your acceleration is looking at the rate at which your velocity is changing. So we've had a couple equations so far, but now we're going to introduce you to the three amigos. These are the three amigos, your three kinematic equations. You are going to need to memorize them. The sooner you memorize these, the easier your life will be. You're going to use them all the time now, pretty much until February. You're going to be using the three amigos in almost every single unit. So memorize these equations. So yes, it's the three amigos, your three friends that you're looking at. So you have VF equals V naught plus AT. This 0 right here is actually means naught, which means original. If you do not like V0, V naught, and you want to use VI instead, that's fine. So you could just rewrite the equation as VF equals VI plus AT. If you're going to be taking AP in the future, you want to get used to the naught symbol because all of the equations in AP are going to be based off of naught. Naught is just, like I said, another word for your original. Okay, so if you look at your units, remember velocity is always in meters per second. So both of those are going to have units of meters per second. Your acceleration is in meters per second squared. And then your time is in seconds. Okay, so those are your units for the first equation. So that's the first amigo. This second amigo is your delta x. So delta x would be looking at your displacement. So that's going to have units of meters. V naught is still going to be in meters per second. Time, always in seconds. Acceleration, meters per second squared. And then time is in seconds. On this equation, it is very important. Your time is the only thing that's squared. So this squared right here is just going to t. It is not going to a. It is not going to the 1/2. The last equation down here is your final velocity. So you have final velocity squared equals v naught squared plus 2a delta x. Again, meters per second for velocity, meters per second for velocity, acceleration, meters per second squared, and displacement is still in meters. Okay, so those are your units. Memorize those equations. You will notice that each one is missing something. So when you write down your givens and your unknowns that you're solving for, there's going to be something that you're missing, so you can pick which amigo you want to use. You can use more than one to solve for something else, but there is an easier way to do it. So if you look at the first amigo, this has no x. So it has nothing to do with distance or displacement. So if you're looking at a problem and it has nothing to do with how far you've traveled, it's not a given, it's not an unknown, you want to use the first amigo. This second amigo is for if you're looking at it and you don't have a final velocity. So if you're looking at something and it never asks for how fast you're going at the end of it, use the second amigo. And then the third amigo has nothing to do with time. Okay, if you'll notice though, All of them have your acceleration and V naught. Okay, so when you're looking at your equations to use, you're writing down your givens. If you don't have acceleration and you don't have velocity, something's probably wrong, or you're about to have to use multiple equations. Okay, so that's just a way for you to look at it to figure out which equation you're using. Some people struggle with this. It's practice, trying to figure out which amigo you're going to use. So just practice, memorize these equations. So within using the 3 amigos, okay, there's a couple times when you can use them. And by a couple, I mean these are what has to be true in order for you to use the amigos. So in order to use the amigos, you have to have a constant acceleration. That can either be a constant positive acceleration, it could be a constant negative acceleration, or it can be 0. So if you're looking at a problem and it says that it's changing your acceleration, so this is talking about the person that, like, you're driving behind on the freeway that speeds up and slows down constantly, that the amigos don't work for this person. Okay, this either works for the person that's steady on the gas pedal speeding up, or steady on the brake slowing down, or that's driving on cruise control. If you have a 0 acceleration, this means that you're moving at a constant velocity or a constant speed. Okay, if you're moving with a positive or negative acceleration, that means your velocity is changing. And then remember from the last unit, the last lecture, we talked about if your velocity and your acceleration have the same sign, you're speeding up. If your velocity and your acceleration have different signs, you're slowing down. And then this is just a little cartoon that we put on here. So it says, Wile E. Coyote's gravity lessons. Remember, in the cartoon world, gravity never works until you look down. You've watched those cartoons before. They run off the edge of the cliff, and then they look down, and then they fall. Until they look down, they haven't started to fall. So in the world of cartoons, don't look down. Otherwise, gravity's going to start to act on you. I know. Physics humor, sorry. Alright, so when you use the amigos, you're only going to use them in one direction. So what that means is you're either going to use the amigo in the horizontal direction or the vertical direction, but not both. So if you're given a delta x value, so a displacement in the x, you cannot combine that with a y acceleration like gravity. You have to separate those things out. For this unit, we keep everything as either horizontal or vertical. We don't make you move in 2 dimensions yet. That'll be coming up in the second unit. So when you're looking at the amigos, I know the equation says delta x. If you're talking about something falling, delta x just becomes delta y. So here you have a cannon being fired. It's moving in both the x and the y direction. So you would have to split those into x and y components. Don't worry about that yet. Again, we will approach that in the next unit. So don't worry about both directions right now. All right, look at your homework at number 30. We're going to go through a couple examples. So number 30, sorry, I'm like trying to get my homework sheet out so I can do this one with you guys. So number 30, a shuttle bus slows to a stop with an average acceleration of negative 1.8 meters per second squared. How long does it take the bus to slow from 9 to 0 meters per second? Okay, so you're going to start this problem writing down your givens. So it tells you your acceleration. So A is negative 1.8 meters per second squared. Okay, then it tells you you slow from 9 to 0. So that means your initial velocity is 9 meters per second. And then your final velocity is 0. Okay, and if you're looking for what to solve for, it says how long does it take? How long? Long is a time frame. Okay, this is my pet peeve about living in Houston. Okay, I get it. Y'all say how far something is, and people answer in terms of time. Far is a distance, long is a time. I understand it. I thought it was crazy when I first moved down here. Everyone kept saying how far something was and kept looking for time. I understand that distances in Houston are relative because something can be 5 miles away and it takes you 15 minutes to get there or 40 minutes to get there depending upon traffic. The problems are not set in Houston. So if it says how long, it wants a time frame. How far, it wants a distance. Okay, so just as like a pet peeve of mine, just for wording purposes. So if you look back at your amigos, okay, you have VF, you have VO, you have A, and you're looking for T. So that means we're going to use the first amigo. So I have VF equals VO plus AT. And the first thing I'm going to do is I'm going to solve this equation for time. So to do that, I'm going to subtract VO from both sides. So I'm going to end up with VF minus V naught equals AT. And then I'm going to divide both sides by my acceleration. You need to show your work. Don't skip steps. So then that means you're going to end up with time is equal to VF minus V naught over A. Now I can plug in and solve. So my final velocity is 0 minus 9 over negative 1.8. And I get a time of 5 seconds. Okay, you'll notice the negative cancels out. 0 minus 9 is negative 9 divided by negative 1.8. Time can never be negative. If you solve a problem and you get a negative time, you are wrong. Okay, you don't have a time machine, and if you do, that's awesome. You're probably a millionaire by now. So you probably don't really have to take this class if you figured out how to build a time machine. So since you don't, time can never be negative. Okay, time is always going forward. So if you're working out a problem and you get a negative time, something's wrong. Okay, fix it. All right, next one we're going to look at is number 34. So 34 says a soccer player runs at a constant speed of 2.6 meters per second for the next 18 meters. He speeds up with an acceleration of 0.45 meters per second squared. What is his speed at the end of the run? Okay, so again, write down your givens. So my initial velocity is 2.6 meters per second. My displacement is 18 meters. And I know my acceleration is 0.45 meters per second squared. And I'm looking for how fast am I going at the end, so I'm looking for VF. So again, you're going to go back and you're going to look at your amigos to see which one has V naught, delta X, A, and VF in it. And that would be the third amigo. So VF squared equals V naught squared plus 2A delta X. So solve it for VF. I'm going to square root both sides. So VF equals V naught squared plus 2A delta X. That squared on the right hand side does not cancel out, okay, with the square root, because you're square rooting last. So really you can think about everything being in parentheses. Okay, so then plug it in. VF square root of 2.6 squared plus 2 times my acceleration. I don't know why I keep trying to write my acceleration wrong. 0.45 times my displacement, which is 18. Plug it in your calculator. Even though the answers are on the page, please make sure you're typing this in the calculators to make sure you know how to do it. .79 meters per second. Okay. Another thing to do with this is to check and see, does your answer make sense? Okay. If you look on your signs on things, your initial velocity was positive. It was 2.6. Your acceleration was also positive, 0.45 meters per second squared. Since your velocity and your acceleration were both positive, that means you're speeding up, which means that your final velocity should be bigger. So if you got something that was smaller than 2.6, again, that's another way for you to check your answers. So that way you can just make sure you're doing the problems right. So as I'm going through this, part of what I want y'all to see is just ways that you can check your work, so that way as you're like working on these problems, you don't freak out, okay, and get stuck. So remember, if there was to be a pop quiz, all the other quizzes from here on out are going to be pop quizzes. If it's a challenge problem, so 36, 40, 41, those will never be on quizzes. They can appear on the test, but they will never appear on a quiz. So just keep that in mind as you're working on the homework. So if you get stuck on one of those 3 problems, it's okay. They're meant to be hard problems. Okay, so that's going to transition us into our next unit. So I have a little video for y'all to watch. So I want you to watch the video and with your group, so the people at your table, and come up with at least 3 physics observations. Okay, so 3 things that are related to physics. Okay, sorry, this is a really old video. Okay, so this is from the moon, and they're going to drop a hammer and a feather to see which one hits the ground first.
Well, in my left hand I have a feather, in my right hand a hammer. And I guess one of the reasons we got here today was because of a gentleman named Galileo a long time ago, who made a rather significant discovery about falling objects in gravity fields. And we thought that where would be a better place to confirm his findings than on the moon. And so we thought we'd try it here for you. The feather happens to be appropriately a falcon feather for our falcon. And I'll drop the 2 of them here, and hopefully they'll hit the ground at the same time. How about that?
Okay, so you can see that the 2 things hit the ground at the same time. So discuss for a minute with your group some of your observations. Okay, so come up with at least 3 physics observations. So telling me that there's an astronaut on the screen, that's not a physics observation. So there's a bunch you could have came up with. You could have said that the 2 objects are accelerating, so they both started from rest and then fell to the ground, so you could say that they're accelerating. You could say that they have a negative displacement because they're both traveling south. You could say that they both have an initial velocity of 0. So there's lots of different ones that you can come up with. I'm sure y'all probably came up with way more than what I just said, but I just named the easiest 3 that I could think of. Alright, so the last thing I want you to do is think about this question. Is this free fall? Okay, So when you're thinking about free fall, you're thinking about gravity. Okay, so is a ball being dropped, thrown up, thrown at an angle, up or down, thrown down, bounced, or thrown horizontally? Are those in free fall? Okay, so a ball being dropped, you think about it, is the only thing that's acting on it gravity? Yes. Okay, that is free fall. Is it being thrown up? Is that considered to be free fall? Yes. Because once it leaves your hand, the only thing that's acting on it is gravity. Gravity's slowing it down, gravity's speeding it up. Thrown at an angle up or down? Yes, that is also free fall. Again, once it leaves your hand, that's the only thing acting on it. Thrown down. Okay, this is another yes, technically. Okay, so thrown down is kind of a weird one to look at it. We normally don't do the thrown down problems just because they add an extra piece to it. So when we're looking at free fall, we're not really going to consider too much about the thrown down. Same thing with bounced. When something's bouncing, you're having another force interacting with it with the floor. And then if it's thrown horizontally, this is also considered to be in free fall. Okay, and again, we'll look at that more as to why that is. The main ones we're going to worry about in this unit are going to be the top two. Okay, so those are like the most important ones for this unit to worry about, is the fact that if something's dropped or if it's thrown up, it is in free fall. Okay, so that is it. Y'all have homework tonight.